Welcome to the Cedar Point wind farm, and we're in the middle of construction of Enbridge's 7th wind farm. It's the first here in the U.S., 139 wind turbines, 252 megawatts. It'll be Enbridge's largest wind project and green energy project to date. Today we're going to go on a little tour of the wind farm. We're going to take a close-up look at some of the wind turbine components. We'll take a look at the erection process, and then we're going to get inside a wind turbine, take a look out the top and get a bird's eye view of the wind farm. Construction started on the Cedar Point wind farm back in August of 2010. Last fall, the majority of the work was civil construction, building the access roads and the turbine foundations. Enbridge had a great opportunity to form a partnership with a local community and the town of Lyman, Colorado. We've had the opportunity to make several donations to first responders in the area through the Safe Community program at Enbridge. We've become a member of the Chamber. We've put an Enbridge sign and advertisement up for the local golf course, and we've been able to make a donation to the Child Development Center here in town. Here we're taking a close look at the turbine components. The towers are rolled steel. They're assembled and manufactured just like some of our mainline pipe in the pipeline business. There's longitudinal welds and there's girth welds on the tower. The tower is divided into 3 sections. Once it's assembled, it'll sit 80 meters high, and the nacelle will be on top of it. In front of the nacelle is the hub, which holds the 3 blades, which capture the wind energy. What these guys are doing are assembling the sensors on top of the cooling tower, which detect the wind speed and wind direction to tell the turbine's computer what direction to face in order to face into the wind and how to pitch the blades. We're assembling the cooling structure that sits on top of the nacelle. The blades at Cedar Point are over 150 feet long. They're manufactured of fiberglass. The manufacturing plant is located here in Colorado, and they're being trucked to site. The truck has an actual separate trailer because of the length of the blade that sits separate and has the ability to steer at the back end. The state of Colorado has been a leader in the U.S. for renewable energy. It's adopted a renewable portfolio standard which requires the utilities within the state to generate a certain portion of their energy from renewable projects. Because of those types of government policies, Vestas, the turbine manufacturer, has set up manufacturing plants here. The blades are manufactured here in Colorado, as well as the nacelle and the tower sections. Here we're lifting our blade. We're doing single blade erection. We're using what's called the blade gripper. It's a tool manufactured by Vestas, the wind turbine manufacturer. It's different from what was previously used, a typical cradle that cradled the blade. This one actually grips hold of the blade and makes the release and the erection process almost 20% faster.
Tag lines looking good. Clean the crane.
There's a guy in the hub ready to receive the blade. He's given directions to the crane operator so that the crane operator knows exactly how to rotate and move the blade in the air. There's 2 tag lines coming off the front of the blade to help in the control and orientation of the blade as it gets fit into the hub. The blade will be fastened to the hub in a similar fashion that we do on our pipeline system. There's a flange connection and bolts that hold the blade in. Wind farm sites are selected due to a good wind resource, but during construction it really can be a hindrance. When the wind picks up to over 22 miles an hour, we need to shut down this activity. In fact, in the first 2 months of work here, we've had over 20 days of what we call a wind out or a shutdown of the crane work due to high wind speeds. At this point, the blades are fastened to the hub. We're getting ready to pull the tag lines off and the crane will release the blade gripper and come back down to pick the next blade. Cedar Point has 2 substations. You can see the electric transmission line coming from substation number 1 in here to substation number 2. I said earlier there's 139 wind turbines at Cedar Point. 70 are connected to substation 1. That energy comes through this transmission line into substation 2, where we pick up the energy from the other 69 turbines on the project. The electrical infrastructure at Cedar Point is designed a lot like the infrastructure in your house. The substations are the circuit breakers in your basement, And the turbines are on circuits just like your outlets are on circuits in your home. So in the substation we have several breakers that are bringing in the energy from about 10 to 12 turbines. From there, all the energy is connected on a bus structure. And then the energy goes through a transformer. The transformer steps up the voltage to that of the transmission line. And then we carry the energy along the transmission line about 42 miles to our point of interconnection with XL Energy. From there, we have a meter. The energy goes through a meter. We read the number of megawatt hours that are transmitted onto XL Energy system. And then that's our billing system for the Cedar Point Wind Farm. Welcome to rush hour at Cedar Point. You can see we're in the middle of delivering the turbine components to the turbine sites. Here we have several blades lined up waiting for delivery and offloading. There's a lot of communication and coordination involved to make a project like this happen. In fact, on site we have a pod, or a plan of the day meeting every day in the morning just to talk about the timing of the deliveries, what's taking place, and who needs to work with who throughout the day. At Cedar Point we have many partners and they need to work together as a team. We have RES, the general contractor, and they're really the ones responsible for coordinating and orchestrating the execution out here in the field. In addition to RES, or working for RES, we have several subcontractors. We have Turner Brothers. They're providing the crane services in the offloading and the turbine erection. We have Vestas, the turbine manufacturer, who is doing inspection of the turbines as they come in. They're doing some of the more detailed connections of the turbine components as they're assembled. We have Lone Star. They're providing all the transport services on the project. A few minutes ago you saw the nacelle sitting on the ground. It's that big, large box that weighs about 100 ton. Now we're inside of one 250 feet up in the air. Just to my right is where the hub is attached to the nacelle. The blades are attached to the hub. There's a shaft right underneath where I'm sitting. That's where the rotational energy goes into the gearbox. Then from there, we have a generator. This project has been several years in the making. You can see how far we've come. Last September, we started with the civil work on site, building the roads, the turbine foundations, and now we're right in the middle of erecting the wind turbines. We have about 35 of the turbines up, standing. We have 139 wind turbines to commission. Our schedule is to commission one a day. So the plan is to be done with commissioning and have the wind farm up and operating by the end of the summer of 2011. Once in operation, we'll have approximately 25 people working at site, maintaining and operating the wind farm. Thank you for joining me today on the tour of the Cedar Point Wind Farm. It was my pleasure to show you around, and I really hope you enjoyed learning more about Enbridge's wind energy projects.